Okay, we're looking at the 6.1c practice quiz. It says, Joey says that if every student in his AP Statistics class of 18 students picked a number at random from 1 to 226 and did this very many times, that about 50% of the time, at least 2 students would pick the same number. You think this is an amazing claim because there's only 18 students and there are more than a dozen times that many numbers to choose from, because 18 times 12 is more than, or that number is less than 226. So there's more than a dozen times as many as 18. You and your classmates are very skeptical, so you want to carry out a study to prove that Joey is wrong. But because this is a quiz, you have to carry out a simulation all by yourself. Number 1, to reduce any chance of bias, some people will have favorite small numbers, like 7, for example. Have your calculator randomly pick a lower bound number between 1 and 750. And the way you do this is you run the command random integer, and then your lower bound is 1, your upper bound is 750. This number will be the lower bound for your range of numbers. Then add 225 to your starting number to get the upper bound. Record your range of 226 numbers and how you obtained this range below. So basically, what I did is on my calculator, I did math probability 5, which is the random integer command. Put 1 comma 750, close my parentheses, hit enter, and it told me 725. So when I added 225 to that, I got 950. So my range is 725 to 950. So what that means is that when I go down here and I select my numbers, I'm going to be counting off by 3 digits, and I'm going to ignore every number from 000 to 724 and 951 up through 999. So I'm only looking for numbers inside this range for my 18 students, and then I'm looking to see, do I get a repeat or not? Do I get a match? Question 2. Now use the random digits table starting at line 113 to generate 18 numbers representing the numbers chosen by your classmates. Record the numbers from the table and underscore or underline the numbers that are in your range. So this will be different for every single person. Make sure you include the upper and the lower bounds. When you find 18 numbers in your range, write them in a list and check and see if there's a match. If there is a match, write match. If there's no match, write no match. Make sure you provide enough details so that your teacher can follow your reasoning. So technically what you should do first, at the beginning of the problem, is to say, I'm going to count off by 3 digits. I'm going to ignore any number outside of the range that I have. I'm going to stop counting when I find 18 numbers. And then you go about and you do this. And for me, I counted off by 3s, and I only found these 6 numbers in the 4 lines that they gave me. So if you can't find all 18 numbers in lines they give you, you have to go to your random digit table and continue after line 116. So I said over here, now I continued from line 117 until I found all 18 numbers. And so these are my other numbers that I found going through the lines. The last number, my 18th number, was on line 122. So you can see it took a lot of lines for me to get all 18 numbers. I looked through here. I didn't see any matches, any duplicate numbers, so I said there was no match. Question 3 says, repeat the process once more and record the results as before. Start at the beginning of the line following the point where you left off. So since I was on line 122, I'm now going to start from line 123. As I worked through line 123, I don't have it up on the screen, but I was recording my numbers in blocks of 3 like before, and once I got my 5th number, I found a match already. So I just stopped right there because I already found my match. Said there was a match. Question 4 says, finally, do you think it's possible that Joey's claim might be correct? Explain briefly. So, first off, this answer is not the answer that's in the answer key, but I'm going to explain this, what I have. So, I think what they want you to think, what they want you to answer if you don't understand statistics, is just to say, oh, well, Joey's claim could be correct because the 2 trials I did, I found a match 50% of the time, 1 out of 2 times. But we only did 2 trials, and 2 trials is an incredibly small sample size. It's not enough of a sample size to determine whether Joey's correct or not without doing our trial a whole bunch of times. So really what we need to do is have a much larger sample size. So if every kid in the whole class did this, we got a match 50% of the time, then we might be okay with saying Joey could be correct. So basically, there's 21 students in our class. If all 21 of you guys did this trial and 10 or 11 or more of you found matches, then you can say that Joey's probably correct. But if not even half of you guys are finding matches in that large of a sample size, then Joey's probably not correct. Like, it could be complete coincidence that I happened to find a match on my second try. Maybe most of you guys don't find matches at all. It's entirely possible. We don't know. Basically, what you should put for here is he could be correct, but you can't really be sure at all until you do more trials. For example, you need a larger sample size in order to have any solid conclusions. Okay, that's all of 6.1c.